All right, this is chapter 2, lesson 6 on page 65. So these are some famous theorems from geometry, and they are Euclidean theorems. Euclid is a guy that came up with so many of our theorems, and he really did a lot with plane, P-L-A-N-E, geometry. The first one goes all the way back to the Greeks, although Euclid, it's in his book. It's called the Pythagorean theorem. Somebody tell me what you know about the Pythagorean theorem, David.
A squared is a squared plus b squared equals c squared.
Okay. We know an equation. What else do we know about it? The Pythagorean theorem. Elliot?
That if you want to like find out like the length or the with the triangle or something, the a squared or the a part of the triangle is like the base. The b is the is the what, and then c squared is hypotenuse.
Okay, key word. C squared is the hypotenuse. So the Pythagorean theorem only works for what types of triangles? Yes? Landry? Right triangles. Right triangles have how many right angles? One, only one. The other two angles are, Selby? They're acute, that's right. There's also something else true about the other two angles. Elliot?
They both equal the hypotenuse. Well, if one's 90 degrees, then they both have to be 45 degrees.
Okay, they don't both have to be 45. This could be 30 and that could be 60, right? But what must they add up to? Yes, Megan? 90 degrees, which we'll learn is complementary. So the sum of these acute angles has to equal 90 degrees. All right, so A and B have the same name for the triangle. They're called legs. The legs of a right triangle, one's the base, one's the height, always. But they're called legs. C is always the hypotenuse, all right? Look at the location of the hypotenuse. The location of the hypotenuse is opposite the right angle. Do you see that? It's always opposite the right angle. It is always the longest side of a right triangle. Always. It will never be shorter than any leg. All right? So, if A is 3 and B is 4, we can calculate C, right? Tell me, Ethan, what formula? Tell me to write the formula with these numbers.
Okay, so we do a squared plus b squared equals c squared. So we start off with the 3 squared would be 9, and then we would add 4 squared would be 16, and that should equal the c squared, which would equal 25, and then the square root of 25 is 5. So that's the length of your hypotenuse.
That is called a Pythagorean triplet. 3, 4, 5. All right. What if instead of that I had how would I solve for this piece? I feel like I need to move down. I'm not going to move down. David.
You do a squared, so it'd be 36.
6 squared, which is 36, plus
100. No, it'd be minus. It would be 100 minus 36, right? You'd subtract a squared from c squared.
So I could go back to this original equation, right? Subtract a squared from both sides, that's algebra, right? And I have b squared equals c squared minus a squared. right? So let's rewrite that equation over here. B squared equals C squared minus A squared. So that's 10 squared minus 6 squared. What's 10 squared? 100. 6 squared?
36.
36. What's 100 minus 36? Say it.
64.
64. Take the square root of both sides. What's the square root of 64?
8.
8. 6, 8, 10 is also a Pythagorean triplet. So, if I don't know if the triangle is a right triangle, I can figure out if it's a right triangle by using Pythagorean theorem. Pythagorean theorem only works with right triangles. I'm not going to tell you if it's a right triangle. So if I just give you that triangle and ask you if it's a right triangle, we can figure it out. What would you put in for A and B? David?
A is 5.
Yep.
Or 5 squared, and B is 12 squared.
Why did you choose 5 and 12?
Because it's the base and the height. A is the base, 5 is the base, 12 is the height.
The hypotenuse always has to be the largest.
Because if this is a right triangle, the hypotenuse has to be the 13, the biggest number. Okay, so 5 squared plus 12 squared, does it equal 13 squared? 5 squared is?
25.
12 squared. 13 squared.
166.
Close, 169.
No.
Does that work?
Mm-hmm.
Yes, it does. Okay, what happens if it doesn't work? If A squared plus B squared is greater than C squared, then we have an acute triangle. All of your angles are acute. You should write that down. If the sum of the squares of A and B are greater than that third side, then all the angles are acute. If A squared plus B squared is less than C squared, then guess what kind of triangle we have? Obtuse. All right, so let's just change this one. We'll make it obtuse to 15, and let's prove this. Okay, we have A squared plus B squared. So that's 25, that's 144. What's 15 squared? 225. Does it equal?
No.
No. It's less than. So how did I know? Because I knew that by making that side larger, I make the angle bigger. Is that logical? By making the side longer, I stretch that angle out. I do. Let me think of an acute. Do you know that that's an acute triangle? How do you know?
Because there's no side that's larger than the others.
What's the measure of every angle?
3. They're all equal. It's an
That's the
equal
measure of
value.
a side. What's the measure of every angle?
60.
60. Because every equilateral has equal angles. Okay? They're the exact same measure. All right, so I know that's an acute triangle. Let's see what this looks like in the formula to see if this in fact works. 3 squared plus 3 squared equals 3 squared. Okay, that's the only acute one that I knew would work. I mean, I could have picked any number, right? 9 plus 9 equals 9. No, it's greater than, right? All right, so that is an important concept to know, that if the sum of the squares of two sides is greater than that third side's not long enough to have any angle that's 90 or above. If that other side is so much bigger that when I square it, it's bigger than the sum of the squares of the other leg, then it's an obtuse because I have stretched that side out. All right, so it's logical. All right, that's Pythagorean's theorem. Look at the one on page 66. The triangle sum theorem. What is the sum of the angles of a triangle? They always, when they lie on a plane, I will clarify that, the sum is 180 degrees. I don't care what kind of triangle I have. I can have an acute, I can have a right, I can have an obtuse triangle, but when I add those three angles, assuming they're lying on a plane, that triangle lies on a plane, that is not true in the case if a triangle lies on a curve. The sum is not 180 degrees because of the curve. But it is true when the triangle lies on a plane. The sum will always be 180 degrees. All right, look at the two circle theorems. Circumference. What is the circumference of a triangle? What's the formula? What's the formula for circumference? And what does circumference measure?
The inside.
Circumference does not measure the inside. Selby?
The perimeter.
Yes, perimeter. So we made up this new word for a circle, and we call it circumference, right? But it is literally the perimeter of the circle. Or, if I have a circle, and I just take some scissors and I cut it, and I lay it out straight, that's the circumference, right? It can also be called the length. So the circumference is the same as the perimeter, is the same as the length of the whole outside of the circle. I also want to introduce you to that word length because that is used in some textbooks. I've seen it on the ACT. All right, but the circumference, we have two formulas for circumference. What are they? Yes, Selby.
Radius times diameter. Sorry, pi times the diameter. And what should I say the other one?
Sure.
And the other one is pi r squared. So pi times the radius.
Nothing squared because we're in one dimension, right? We're measuring, that's why I lay it out. We're measuring one. What is it, David?
It's pi r times 2.
2 pi r. Okay, I want us to look at this formula. There is something amazing about this formula. Does pi ever change?
No.
The value of pi is a constant. We will always leave pi as pi in this class. On your calculator, pi is towards the bottom, I believe, but you don't need it. You just leave pi as pi, okay? Look what is true about pi. And maybe y'all have already talked about this. If I take this equation and solve it for pi, that's just algebra, right? What's the value of pi always equal?
3.1.
No, that is incorrect. Yes.
Value of pi equals pi. So that's true.
That is a true statement. The value of pi always equals pi.
Isn't it like 21 over 7 something?
No.
Circumference divided by diameter.
That is correct. It's the circumference of any circle divided by its diameter. Okay, now let's just contemplate that for a little bit. If I have a very small circle, the value of pi is pi. It will equal the circumference divided by the diameter.
You'll get the same number.
As if I have a huge circle. Pi will still equal the length around that circle divided by its diameter. Is that not amazing to contemplate? That value doesn't change? Even as the circle changes, pi never changes. That value never changes.